Hi class, today we're going to take a look at the basic trig functions. Basic trig functions all deal with right triangles, and I have two right triangles here. And these right triangles have been strategically made so that the angles will end up matching. So this angle here is the same as that angle. This angle is the same size as that angle, and then our right angles are both here. In a triangle that is a right triangle, and a right triangle means it has a 90-degree angle in it, which you can see right here because these two sides are perpendicular on both these triangles. In the right triangle, the side called the hypotenuse is the one across from that 90-degree angle. So in the small triangle, that's 10, and in the big triangle, that's 15. So let's name that the hypotenuse. The other two sides are what we call legs. And in our trig functions that we're going to be talking about, we talk about those in terms of where they are in relationship to an angle. So we're going to be looking at this angle here in the blue triangle, which corresponds to this one here in the black triangle. And I'm just going to call that x, and it's really x in both of the triangles because it's the same size in both of the triangles. Essentially, the blue triangle is just the black one enlarged. You can imagine putting it in a photocopy machine and enlarging it up to the size of the blue one. So when we're looking at that, in terms of the x, the side across from it, the one that you can draw a line to from the angle. So from x I can draw a line to 8, or in the bigger triangle I can draw a line to the 12. That one is called the opposite of x. It's across from it, so it's the opposite. And then the remaining triangle is the one that's right next to it. And to be right next to something, you are adjacent to it. So that side is called the adjacent. Now, to simplify the ratios we're going to make, rather than writing the entire words, we're going to use a capital H for hypotenuse, a capital O for opposite, and a capital A for adjacent. Now, before we find out those ratios, I want you to think of all the different ways we could write a fraction if we have three different numbers. In this triangle, one way we could do it is we could take the side across from the x, which in the big triangle is 12, and divide it by the hypotenuse, which is 15. So notice when we do that, we get 12 over 15. If I reduce that fraction, I notice that 3 goes into both of them. And 3 into 12 is 4, and 3 into 15 is 5. Let's see what happens when we do the same thing with the similar triangle that's smaller than it. If I go across from the x, I get 8, and then my hypotenuse here is 10. That gives me the ratio 8 over 10. Notice that can also be reduced by dividing the top and bottom by 2, and that gives me 4/5. Notice that in either triangle, because they're similar to each other, it doesn't matter which one you use. Once you reduce it, you get the same ratio. And a long time ago, somebody who obviously didn't have much to do took all the triangles possible and found out all these ratios. And now they're stored in your calculator. And they're stored under some different functions. And we're going to take a look at what those functions are and which ratios they're talking about. So let me give some room here, and we'll write out those ratios. The first ratio is the sine ratio, which is written out like this, but on your calculator you might see something that says sin. Sine of some angle x, in this case because our triangle has the x in it, is always the opposite side. So if you take x, go across to the opposite side, which we're going to use the O for, divided by the hypotenuse. It's that ratio, the one that we just looked at. So that's going to be opposite over hypotenuse. Another fraction that we could make with the three sides of this triangle here is we could take the adjacent side. Instead of using the opposite, we could use the adjacent side over the hypotenuse. That's called cosine. And cosine is in shorthand is COS. If you spell it out, it's co and then sine, just like we spelled with the sign for the function sign. So cosine of an angle x is the adjacent, which we're going to use the A for adjacent, over the hypotenuse. And the last basic one that we have is called tangent. And tangent on your calculator is TAN. However, the entire word is TANGENT. And tangent of x is the other thing. Notice we've already made two ratios with hypotenuse in it. If we're going to make all the combinations of these three sides, we can't use the hypotenuse again. It's already been used as much as it can. The other thing that we can do, though, is we could make a ratio with the opposite and the adjacent. So that's what the third basic one is going to be. So opposite over adjacent is the third one. And that is your tangent. And you might be saying, well, if I'm going to do all the combinations of these, then couldn't I flip all these fractions over? And if you want to flip all these fractions over, you actually do get 3 more trig functions. Those trig functions aren't really going to be used in our courses until you get up to pre-calc. But there are 3 other trig functions that are a little bit beyond this. Let's go to a new page and we'll write all those out. Right now we have sine of x is opposite over hypotenuse. We have cosine of x is adjacent over hypotenuse. And we have tangent of x is opposite over adjacent. If we flip all those over, we can also make fractions that are h over o, h over a, and a over o. Now, what are those called? The one that's h over o is called cosecant. For shorthand, we do CSC. So cosecant of x is the sign flipped over. The other one that we have is secant, and that's the cosine ratio flipped over. And the last one is cotangent. And cotangent is the tangent one flipped over. Now obviously tangent and cotangent sound like each other, so they go together. They're easy to remember. But how do you remember which one of these goes together? Because this one is just that one flipped over. Well, notice sine starts with an S, cosecant starts with a C. Cosine starts with a C, secant starts with an S. Notice that the C always goes with the S. So if you have sine and you're going to flip it over, it's not going to be secant because secant starts with an S. It's going to have to be cosecant because it starts with a C. That's one way that you can remember these. Another way to remember at least just these basic things is a lot of people have heard SOHCAHTOA. SOHCAHTOA is so, ka, toa. These are just the initials. It's like an acronym to remember the 3 basic ones. You won't have to worry about these ones too much until you get to pre-calc. We're going to need to remember these. So SOA is sine is opposite over hypotenuse. Ka is cosine is adjacent over hypotenuse. And TOA is tangent is opposite over adjacent. So you can use this acronym to help you remember the ratios when you're doing your problems. Now let's go back to our previous page and we're going to find our sine, cosine, and tangent. If we're finding sine of x, that's going to be using our acronym SO, CA, TOA. We're going to be looking for sine is opposite over hypotenuse. So opposite is 8 and hypotenuse is 10. So we're doing 8 over 10. Now when we did this before, you noticed that we had to reduce this. You do always want to reduce these to simplest form. So if you divide the numerator and denominator by 2, this becomes 4 over 5. Now the cosine Cosine starts with C, so we're going to look at ca. Cosine is adjacent over hypotenuse. The adjacent to our x angle is the 6, and our hypotenuse is 10. So that ends up being 6 over 10. Again, reduce it, and we end up with 3 over 5. And the last ratio we have is tangent. If we're looking at tangent of x, we want to look at TOA. So tangent is opposite over adjacent. The opposite of x is 8, and the adjacent is 6. So this is going to be 8 over 6, which again we can reduce to 4/3. Now it's good that we made these first, because if we now want to get those other not so basic trig functions, all you really have to do is take these fractions and flip them over. The reciprocals are going to be these other three. And if these are already reduced, just use the reduced form. So since C goes with S, sine goes with cosecant. If I flip the sine one over, I get 5 over 4. And cosine starts with a C, so it needs to go with secant because it starts with an S. So I can use the reduced form of 3 over 5, flip it over, and get 5 over 3. And then finally our tangent goes with cotangent. Take the reduced form of 4 over 3, flip it over, and you get 3 over 4. And that's how you would just write those basic ratios. Now, what if you actually wanted to use these to solve some kind of a problem in real life? Well, a lot of things deal with right angles. And let's say that you have a, you don't want to climb all the way up to the top of the tree to figure out how tall it is. Well, you can go out, if it's on flat ground, you can go out a certain distance, and let's say that you go out on the ground and you've traveled, say, 20 feet. You can take a little angle measuring device and measure the angle up to the top of the tree. And let's say that you find that this angle up to the top of the tree, 20 feet out from its base, happens to be, say, 24 degrees. You can now use that to find the height of the tree, and you don't even have to climb the tree, which is awesome. So now we have to take a look and say, okay, this is going to involve trig, but which ratio do I use? Do I use sine, which is the SOA? Do I use cosine, which is ca? Or do I use tangent, which is TOA? Well, let's look at the sides involved with this problem. You've got this angle, and across from it is the height, and the height is what you want. You also know the adjacent to it here. Well, opposite adjacent is in TOA, so that's the one that you have to use, because those are the sides involved in the problem. So you would say that tangent of 24 degrees equals the opposite, which is the height of your tree, over the adjacent, which is 20. If you solve this equation, you'll end up finding the height of that tree. So to solve this equation, the first thing you want to do is get rid of your fraction. So we're going to go ahead and multiply both sides by, so let's multiply both sides by 20. When we multiply both sides by 20, these 20s cancel, and your height is 20 times the tangent of 24 degrees. Now you can go to your calculator, and as long as your calculator is in degree mode, you do want to check that, you can just do 20 times tangent of 24, and that will give you that it happens to be 8.9, if you're rounding to the nearest tenth, feet tall. And you didn't have to climb up it. What if you also wanted to know, well, if you needed some kind of a string to hold it up in the wind, and you wanted to tie that string to the top of the tree up here, and affix it to the base of the tree way down here. How long would this string need to be here? Well, let's give that string a letter. Let's call it C. Now, instead of doing tangent, we're going to need to do something else. We're no longer solving for H anymore. We're now solving for C. So let's look at which ones of those are involved in this particular problem. If we want the wire to go from the base right here to the top, we want C, and C in this particular triangle is your hypotenuse. And the other thing that we know is the 20 feet here. If we know the 20 feet here and we need the C, the 20 feet's adjacent, the hypotenuse is C, adjacent hypotenuse, that's in your cosine right here. So let's use cosine for this one. This is going to be cosine of 24 degrees equals the adjacent, which is 20, divided by the hypotenuse, which is C. To solve this, we need to first get rid of our fractions. So let's multiply by our denominator, which in this case is C. So if you multiply by C, you end up with C cosine, and there's the times there, 24 equals 20. Now you actually have to go ahead and get C by itself. So since C is multiplied by the cosine of 20, which is cosine of 20, or excuse me, cosine of 24, which is basically a ratio that your calculator has stored, in order to solve for C, you divide by that cosine of 24. So those cancel, and C ends up being whatever 20 divided by cosine of 24 is. So now in your calculator, you do need a scientific calculator of some sort for this. You can just take 20 divided by your cosine button, make sure you're in degree mode, 24, and then that will give you that you need a string that's 21.9 feet tall, and that's if you round to the nearest tenth. So that's your basics on just some basic trig. As you move on in your math career, you'll find that you'll expand on these quite a bit more. But for right now, that gives you a little bit you can use in real life.